Alright, so picture this. You're in a SQL interview at Amazon, and the interviewer pulls up a table of daily transactions, thousands of rows, order IDs, amounts, dates, and then they say, "Show me how total revenue grows over time. I want to see the running total after each day." Now here's the thing. You could group by date and get the total for each individual day. That's easy. But that's not what they're asking. They want the cumulative total. Day 1's revenue, then day 1 plus day 2, then day 1 plus day 2 plus day 3. Each row should show the total of everything that came before it, plus itself. This is one of the most common patterns in FAANG SQL interviews. It shows up at Amazon, Netflix, Stripe, and honestly almost everywhere that deals with time series data. And the tool you need is something you might have already seen in episode 1, window functions. But this time, we're going deeper. We're going to learn about frame specifications, and that's what makes cumulative aggregates possible. Welcome to SQL Interview Patterns, FAANG Edition. This is episode 3, and today we're tackling cumulative and running aggregates. Okay, so let's build up the concept from scratch. And I want to make sure this really clicks, because once you understand this, a whole class of interview questions becomes straightforward. Let's start with something you already know, a regular sum with a group by. If you have a sales table with order date and amount, and you write select order date, sum of amount, group by order date, you get the total sales for each individual day. January 1st had $500, January 2nd had $300, January 3rd had $700. Each row is independent. Each row only cares about its own day. But what if you want each row to show the total of all days up to and including that day? January 1st shows 500. January 2nd shows 800 because that's 500 plus 300. January 3rd shows 1500 because that's 500 plus 300 plus 700. That's a running total. Each row accumulates everything before it. Now here's the key insight. With a regular group by, the database computes one result per group and throws away the individual rows. But with the window function, the database keeps every single row and computes a value across a window of related rows. The window slides along as you move through the data. For a running total, the window starts at the very first row and expands one row at a time. When you're on row 1, the window contains just row 1. When you're on row 2, the window contains rows 1 and 2. When you're on row 3, the window contains rows 1, 2, and 3. The sum function adds up everything inside that window for each row. Think of it like a snowball rolling downhill. It starts small, and with every row it passes, it picks up more data. The snowball only grows, it never shrinks. That's what unbounded preceding means. There's no limit on how far back the window reaches. It always goes all the way back to the very first row. And this isn't limited to sums. You can do running counts, running averages, running minimums, running maximums. Any aggregate function can become a cumulative aggregate when you pair it with the right window frame. But sum is by far the most common one in interviews, so that's where we'll focus. Now let's look at the actual SQL syntax and break it down piece by piece. Here's the query. Select order date, amount, then sum of amount with an over clause. Inside the over clause, we have order by order date, and then rows between unbounded preceding and current row. We alias this as running total, and that's it. That one line does all the magic. Let me walk through each part of this, nice and slow. First, sum of amount. This is the aggregate function. Just like a regular sum, it adds up values, but instead of collapsing rows into groups, it's going to compute a sum for each individual row based on the window we define. Next, the over clause. This is what turns a regular aggregate into a window function. Everything inside the parentheses after over defines the window, meaning which rows participate in the calculation for each row. Inside the over clause, first we have order by order date. This is critical. It tells the database what order to process the rows in. For a running total, the order matters enormously. If you order by date ascending, you get a running total that grows forward through time. Without this order by, the database has no idea what preceding or following even means. You'd get unpredictable results. And then the frame specification. rows between unbounded preceding and current row. This is the part that defines exactly which rows fall inside the window for each calculation. Let me break the frame specification down even further. Rows between tells the database we're defining the window boundary explicitly. Unbounded preceding means the window starts at the very first row in the partition. There's no limit. No matter how far back the data goes, the window always includes everything from the beginning. And current row means the window ends at the row we're currently calculating for, not the row after it, not the row before it, the current row. So put it all together. For each row, sum up the amount from the very first row, all the way through the current row. That's your running total. Now here's something you might not know. If you write sum of amount over with an order by but without explicitly writing the frame specification, most databases will default to range between unbounded preceding and current row. Notice that says range, not rows, and there's a subtle but important difference between the two, which we'll cover in the pitfalls section. For now, just know that it's a best practice to always write out the frame specification explicitly. Don't rely on defaults. It makes your intent crystal clear to the interviewer and avoids some sneaky edge cases. Let me also show you what happens when you add partition by to the mix. Say you have a sales table with the region column and you want a running total per region. You'd write sum of amount over partition by region, order by order date, rows between unbounded preceding and current row. The partition by clause splits the data into separate groups, one per region, and within each group, the running total starts from scratch. So the East region has its own running total, the West region has its own, and they never mix. Think of it like having separate snowballs for each region, each rolling independently. Without partition by, the running total accumulates across the entire table. With partition by, it accumulates within each partition independently. The interviewer might ask for either one, so make sure you understand the difference. Alright, let's talk about the common mistakes people make with cumulative aggregates. These pitfalls are subtle, and they're exactly the kind of thing that separates a good answer from a great one in an interview. Pitfall number 1. Forgetting the order by clause inside the over clause. This is the most dangerous one because the query still runs. It doesn't throw an error, but without an order by, the database doesn't know what sequence to use for the running calculation. The result is non-deterministic, meaning you could get a different answer every time you run the query. In some databases, without an order by, the frame specification is ignored entirely and you just get the total sum repeated on every row. Either way, the result is wrong for a running total. Always include order by inside the over clause when computing cumulative aggregates. Pitfall number 2. Confusing rows with range. This is the sneaky one. When you write rows between unbounded preceding and current row, the database counts individual rows. Row 1, row 2, row 3. Each row is its own unit. But when you write range between unbounded preceding and current row, or when you omit the frame and let the database use its default, the database groups by value, not by position. If two rows have the exact same order date, they're treated as the same point in the range. Both of those rows will include each other in their window, even though they're separate rows. Let me give you a concrete example. Say you have three rows, January 1st with $100, January 1st again with $200, and January 2nd with $300. With rows between, the running total would be first row gets 100, second row gets 300, that's 100 plus 200. Third row gets 600, that's 100 plus 200 plus 300. Each row is processed individually in order, but with range between, because the first two rows have the same date, they're considered the same point in the range. Both January 1st rows see each other and get the same running total of 300. Then January 2nd gets 600. The first two rows are lumped together. In many interviews, the data has unique dates, so this doesn't matter. But if dates can repeat, which is common with transactional data, this distinction is critical. The safe choice is to always use rows between, unless you specifically want ties to be grouped. And when the interviewer gives you data with possible duplicate dates, Mentioning this distinction is a great way to show deep understanding. Pitfall number 3, not handling nulls in the amount column. If any row has a null amount, the sum function skips it silently. This is standard SQL behavior. Sum ignores nulls, but it can lead to confusing results if you're not expecting it. The running total jumps from, say, 500 straight to 800, skipping what looks like it should be a row in between. If the interviewer's data includes nulls, consider using coalesce to replace null amounts with 0 before summing, something like sum of coalesce of amount comma 0. This makes the behavior explicit and shows the interviewer you're thinking about data quality. Pitfall number 4, thinking you need a self-join for running totals. Some candidates, especially those who learned SQL before window functions were widely available, will try to compute a running total using a correlated subquery or a self-join, something like for each row sum all amounts where the date is less than or equal to the current row's date. This works, but it's extremely inefficient. It's essentially doing a full table scan for every single row. Window functions solve this in a single pass through the data. If you reach for a self-join when window functions would work, the interviewer will notice, and not in a good way. Okay, time to put this into practice with a real FAANG interview question. This first one comes from Amazon. Here's the setup. You're given a table called daily revenue with 3 columns: revenue date, region, and amount. The table has 1 row per region per day, showing how much revenue was generated. The question is, for each region, calculate the daily revenue and the running total of revenue over time, ordered by date. Return the date, region, daily amount, and the running total. Let's think through this step by step. First, what are we computing? Two things: the daily revenue, which is just the amount column directly, and the running total, which is the cumulative sum of amount over time within each region. Second, do we need partition by? Yes. The question says for each region, which means the running total should reset for each region. East region accumulates separately from West region. Third, what's the ordering? The question says ordered by date, so we order by revenue date ascending inside our window. Here's the solution. We select revenue date, region, amount as daily revenue, and then sum of amount with an over clause that partitions by region, orders by revenue date ascending, and specifies rows between unbounded preceding and current row. We alias that as running total. Then we order the final results by region and revenue date. Let me walk through what this does. The partition by region clause creates separate windows for each region. Every region gets its own independent running total. The order by revenue date ascending inside the over clause tells the database to process rows within each region in chronological order, earliest dates first. The rows between unbounded preceding and current row frame means for each row sum everything from the very first row in this region up to the current row. Let's trace through a concrete example. Say we have the East region with 3 days of data: January 1st, 400, January 2nd, 600, January 3rd, 200, and the West region with 2 days: January 1st, 300, January 2nd, 500. For the East region, January 1st gets a running total of 400 just itself. January 2nd gets a running total of 1000, that's 400 plus 600. January 3rd gets a running total of 1200, that's 400 plus 600 plus 200. For the West region, it starts over from scratch. January 1st gets 300, January 2nd gets 800, that's 300 plus 500. The regions don't interfere with each other at all. That's the power of partition by. Now, one nuance the interviewer might probe. What if there are days with no revenue for a region? If a day is simply missing from the table, the running total just skips that day. It doesn't show a row with 0. If the question requires showing every date including gaps, you'd need to generate a date series using a calendar table and left join the revenue data onto it. But that's a separate pattern. For this question, we only need to work with the rows we have. Also, notice that I explicitly wrote out the full frame specification, rows between unbounded preceding and current row. I could have left it off and let the default kick in, but writing it out shows the interviewer that I know exactly what I'm asking for. It's a small thing, but it signals confidence with the concept. Let's tackle one more interview question. This one is from Stripe. You're given a table called user signups with three columns: user ID, signup date, and country. The question is, for each country, show the number of new signups per day and the cumulative total of signups over time. Also, calculate what percentage of the current cumulative total each day's signups represent. Alright, let's break this down carefully. This question has three parts, so let's handle them one at a time. Part 1: the number of new signups per day per country. This is a straightforward group by. We count the user IDs grouped by country and signup date. Part 2: the cumulative total of signups over time per country. This is our running total pattern. We use sum over with partition by country. Part 3: the percentage that each day's signups represent of the cumulative total so far. This is just daily signups divided by the running total, multiplied by 100. Now here's the thing, we need both an aggregation, the group by count, and a window function, the running sum. These operate at different levels. The group by collapses rows into one per country per day. The window function then runs across those collapsed rows. So we need to think about the order of operations. The cleanest approach is to use a common table expression. First, we aggregate the raw data into daily counts. Then, in the outer query, we apply the window function on top of those daily counts. Here's the solution. We start with a common table expression called daily counts. Inside it, we select country, signup date, and count of user ID aliased as daily signups. We group by country and signup date. Then in the outer query, we select from daily counts. We pull country, signup date, and daily signups. Then we add sum of daily signups with an over clause that partitions by country, orders by signup date ascending, and specifies rows between unbounded preceding and current row. We alias that as cumulative signups, and for the percentage, we take daily signups, cast it as a decimal, divide by the cumulative sum, which is the same window function we just wrote, and multiply by 100. We round that to 2 decimal places and alias it as percentage of total. Let me walk through this step by step. The common table expression does the heavy lifting of collapsing raw signups into daily counts per country. If 30 people in the United States signed up on January 5th, that becomes one row. Country United States, sign up date January 5th, daily signups 30. Then the outer query takes those daily counts and applies a running sum. For the United States, if January 1st had 50 signups, January 2nd had 30, and January 3rd had 45, the cumulative totals would be 50, then 80, then 125. The percentage column tells us what share of the cumulative total each day contributed. On day 1, 50 out of 50 is 100%. That's the only day so far. On day 2, 30 out of 80 is 37.5%. On day 3, 45 out of 125 is 36%. Notice how the percentage of each day generally decreases over time as the cumulative total grows. That's the nature of cumulative metrics. Let's trace through a concrete example. Say the United States has these signups: January 1st, 50, January 2nd, 30, January 3rd, 45. And Canada has January 1st, 20, January 2nd, 15. For the United States, January 1st gets 50 daily, 50 cumulative, 100%. January 2nd gets 30 daily, 80 cumulative, 37.5%. January 3rd gets 45 daily, 125 cumulative, 36%. For Canada, January 1st gets 20 daily, 20 cumulative, 100%. January 2nd gets 15 daily, 35 cumulative, 42.86%. Each country accumulates independently because of the partition by clause. One thing the interviewer might push on here: why did I use a common table expression instead of putting everything in one query? The answer is clarity and correctness. The count needs a group by, which collapses rows. The running sum needs individual rows to work with. By separating these into two steps, Each step is clean and easy to reason about. You could technically nest the aggregation into a subquery, but the common table expression approach is much more readable, and readability matters in interviews. Alright, let's wrap this up. Today, we covered cumulative and running aggregates, the pattern of computing values that grow and accumulate across ordered rows. We built up the concept from a simple group by to a window function with a frame specification. The key mental model is the snowball, a window that starts at the first row and grows by one row at a time, accumulating data as it goes. We broke down the syntax piece by piece, some with an over clause, order by to define the sequence, and rows between unbounded preceding and current row to define exactly which rows participate in each calculation. We covered the four major pitfalls: forgetting the order by inside the over clause, confusing rows with range when there are duplicate values, not handling nulls in the data, and reaching for a self-join when window functions are the right tool. And we solved two real FAANG interview questions: the Amazon question about running revenue totals per region, which is the classic cumulative sum pattern, and the Stripe question about cumulative signups with daily percentages, which showed us how to combine group by aggregation with window functions using a common table expression. The key takeaway is this: whenever a question asks you to show how a metric grows over time or accumulates across rows, reach for some over with a frame specification. It's clean, it's efficient, and it's exactly what the interviewer expects. Next episode, we're diving into gaps and islands. That's the pattern where you identify consecutive sequences and breaks in your data, like finding streaks of consecutive login days or gaps in sequential IDs. It's one of the trickiest patterns in SQL interviews, and it builds directly on the window functions we've been learning. See you there.